Why do light bulbs shine? How do you get from electricity into light? Why do light bulbs get hot, and why do other hot things like ovens and cups of tea not also glow? I'm Tom, and welcome to Physics Foundry. Let's start with what electrical current actually is, the movement of electrons, here in a loop, around in a circuit. With only wires in the circuit, the electrons can travel very easily around the loop. Introducing a light bulb means introducing a very narrow piece of wire halfway around the loop, which is much harder for the electrons to travel past. Rather than running easily through the wires, the electrons here get jostled around, and this chaotic jiggling is the key to the light bulb's powers. In fact, chaotic jiggling or bouncing around is by definition heat. But how does this jiggling mean that light is produced? Well, these electrons travel crazy fast, so when they bump into each other, they bump hard. In the same way that hitting a vending machine hard enough might get you an extra chocolate bar, hitting an electron hard enough might make it give out, or emit, pure packets of energy in the form of light. Noting that light is just pure packets of energy is actually quite important. All of the light we see is just one small range of energy packets, from red at the lowest energy to blue at the highest. The full range of light is called the electromagnetic spectrum. It stretches from radio waves at the bottom to X-rays and beyond at the top, through microwaves to burn your food and ultraviolet to burn your skin. So back to our problem. Why do light bulbs shine, whereas other hot things don't light up? The hotter an object is, the higher the energy it gives out. The filament in an old-fashioned light bulb, just like this one, is at several thousands of degrees, and most of the light it gives out is in the visible part of the spectrum. The sun lights up for the exact same reason, because the surface of the sun is at about 6,000 degrees Celsius. Both light bulbs and the sun emit many other types of light, but because we can't see it, that energy is essentially wasted. Modern light bulbs use more efficient ways to energize atoms, so only give out the visible light we need. As for tea, it turns out that the jiggling of atoms means it does emit light, but because it's colder, most of this light is just outside the range we can see, in a region called infrared light. Although we can't see infrared with our eyes, there are cameras that can, such as the one filming me now. Understandably, hotter things emit more infrared, so you can see that hotter areas like my neck come up brighter on the display than cooler areas like the board. Interesting facts. Some animals, such as pythons and other snakes, can see slightly into infrared, which helps them to hunt at night by seeing the heat signatures of their prey. So apart from night vision, how is this useful? Well, because lower energy packets are easier to make. Your TV remote actually talks to your TV in infrared. You can see this if you point your remote at your phone's camera and press a button, because most phones' cameras can see slightly into infrared. Other uses of infrared include finding avalanche victims beneath the snow, hunting criminals at night, and even looking at the cold gas and dust in between the stars. So heat and light are very closely linked. The hotter an object, the higher the energy light it gives out. And that is how light bulbs work. Any comments, questions or suggestions, feel free to leave them in the comment section below or on Twitter. And be sure to check out our Facebook and Tumblr pages for more cool science.